Thank you for joining us today to learn more about the EBOM to MBOM transformation process. This session is designed to provide you with the basic information that will help you incorporate this powerful capability into your product development processes. The following challenges are often found within industry. Today, many new product introduction processes struggle with the disconnected nature of the product design and manufacturing planning teams. Other companies separate the manufacturing engineering planning information from the product design information and manage it in completely different systems, or the manufacturing information is only in spreadsheets and paper documents that are not well controlled. The teams responsible for product design, manufacturing process planning, and production often do not work closely together. They each have their own set of activities and key business processes. A core business process that is usually not well integrated is the enterprise change process. This critical process needs to incorporate all of the engineering and manufacturing change activities that are required to fully implement a product design change. In situations where the same product is produced in multiple locations, there are often different methods for handling similar plant-level processes. This results in sub-optimization, lost productivity, and generally reduced operational efficiencies. Delving deeper into disconnected teams, we find it common today for engineering product design and manufacturing process planning groups to operate almost independently. Let me highlight two specific challenges resulting from disconnected teams. One, each team uses different systems to do their work. They are also working with different data and different methods of storing, tracking, and controlling their information. Two, the differences and lack of commonality often results in a wall between the groups. The lack of communication can lead to delays in time to production for new products. The delays in the overall product development process are introduced when the disconnected team environment leads to manufacturing process planning teams waiting until the design is finished before they complete the remaining work tasks. Inconsistent data management results when each area of the business focuses on managing only a portion of the entire product definition. It is common for product design to be totally focused on the development of the product. To do this, they concentrate on the design intent and define the product details based on how they do their work. Product development often organizes their data by the type of design data and groups of design features. It is also common for manufacturing planning to be focused on defining how the product will be produced. They concentrate on the manufacturing strategy and define the manufacturing plan based on utilizing production methods aligned to a facility's capabilities and the factory floor layout. In some cases, manufacturing engineering needs to consider variables resulting from multiple factory locations and strategies. Each group's focus on their own deliverables and data, combined with a patchwork of data transfer method, often results in data translation errors and leads to delays in dealing with design updates and changes prior to the product's start of production. During development, the engineering product development teams will typically perform product design reviews to improve and enhance the product. Manufacturing engineering uses design for manufacturability reviews to identify potential manufacturability issues before production begins. If manufacturing engineering is not involved early in the design process, they will not be aware of key manufacturability issues, and it may be too late to modify the design to eliminate those issues, or the last-minute change requests from manufacturing engineering needed to support the factory requirements can impact the product's start of production date. These separate processes are usually the result of different goals, objectives, and deliverables for each group. These differences limit the organization's effectiveness and lead to missed opportunities. When we look at the manufacturing engineering teams, we see that they have the responsibility to plan production for a single product that could be produced in multiple plants with varying resources, machines, and worker skills. When the companies do not have standard manufacturing processes that include detailed information about a specific factory's capabilities, the manufacturing engineer's job becomes very challenging. Most companies do not have a way to manage a central library of plants, workstations, worker skills, and tools. If manufacturing engineers could leverage existing knowledge, they would be able to reduce the effort to develop manufacturing process plans for multiple plants. The missing management of factory capabilities and manufacturing processes limits the business's flexibility to decide where a product should be manufactured. The business costs resulting from these challenges are significant. Delays in the transfer of design information to the plants, data quality issues, late changes to the design, all have a direct impact on the product development costs, the quality at start of production, and missed launch dates. For the remainder of this session, we will focus on a fundamental process that will enable your product delivery processes. This fundamental process is the transformation of a product's EBOM into an MBOM. The resulting MBOM is required to support all of the manufacturing planning activities and deliverables. Using the right tools and methods to create this critical set of information will give your business a competitive advantage. In the upcoming demonstration, you will see how completing the EBOM to MBOM transformation process within an integrated PLM enables the entire product development team to leverage the 3D models, EBOMs, MBOMs, and product specifications throughout all aspects of the business. Two key aspects of the PTC toolset that will be highlighted in the upcoming demonstration are: 1. The ability to quickly create a restructured and enhanced bill of material from an upstream source, and 2. The capability to create links between the BOM components in different types of bills of material. The restructuring of BOMs allows the business to accurately align the organization of an MBOM's components to match the requirements of an ERP system. Structuring of a service BOM will support a company's aftermarket business processes. The component-to-component links explicitly capture the details of the source and destination of the BOM components between bills of material. This linking also allows the system to indicate how changes to design will impact specific components in a downstream BOM. Let's get started with the demonstration. This demonstration will show how the PTC MPM Link BOM Transformation tool can support the early engagement by manufacturing in the product design process. Traditionally, the design process has included the major activities of concept development, system design, detail design, followed by the development of the MBOM and manufacturing plan to support the production ramp-up and full-scale production. This serialized approach limits the opportunity for manufacturing to influence the design and reduce costs of the product before the design has solidified. Using the MPM Link tool can provide your team an opportunity to overlap the development of the design, the MBOM, and the manufacturing plan. The coordinated design and manufacturing planning activities will lead to a reduction in time-to-market cycle time for your product. It will also shorten the timeline and provides for the collaboration within the product design teams to reduce the cost of changes during the design process, as well as a reduction in the final manufacturing cost. For our demonstration today, we will be using a battery box that is part of an off-road vehicle. Using EBOM visualization, we look at the design by turning off and on the visibility of specific parts to allow for a detailed design review. Changing the part structure view options results in the display of the CAD model details for each of the EBOM components. Continuing a design review, the Part Structure to CAD Structure Compare tool is selected. Confirming the comparison set, the system displays the Windchill Part BOM and CAD BOM in side-by-side panels. Selecting a BOM component on the right side highlights the corresponding component on the left side. Now we begin the EBOM to MBOM transformation by opening the Design EBOM in the Manufacturing Associative Part Structure browser. The EBOM is displayed in the left panel, and the right panel is displaying a partially transformed MBOM. Notice that the 3D visualization provides a good way to understand both the CAD structure and the shape and interfaces between the components in the assembly. For the next step in the BOM transformation, the visualization indicates that the cover has not been placed in the MBOM. Since our manufacturing strategy is to purchase this from an external source, we will use the copy-paste action to create a unique manufacturing part number in the MBOM. The Paste as New Part dialog defines a new part number by adding a suffix to the engineering part number, but other numbers can be used to match your ERP requirements. Once the new manufacturing part is displayed in the MBOM, we will need to edit its source attribute to indicate this is a purchased part. Using the action menu on the cover part, the Edit Part dialog panel is opened. We proceed by picking the Buy option for the source attribute. This is followed by a check-in action to record this change in the PDM link database. A quick visual comparison of the BOMs shows that the MBOM has source defined as buy, and the equivalent EBOM cover part has source defined as make. Checking the design view, we can clearly see that there are two fasteners that have not been placed in the MBOM. Selecting these items directly, followed by a copy-paste action, adds these items to the MBOM. At this point, a review of the design view confirms that all components have been placed in the MBOM. The MBOM is now checked in to the database as complete. Prior to the demonstration, an initial EBOM to MBOM transformation resulted in the placement of 5 fasteners into a kit and a subassembly in the MBOM. To review the distribution of these items, we select the EBOM component and then request the Select Equivalent Parts on Other Side action. This expands the MBOM structure to show where the individual fastener components are used in the MBOM. These items can be visualized by using the Show Selected option in the MBOM visualization panel. A critical aspect of a robust design process relies on the ability for all team members to see the progress of the design and manufacturing engineering teams. Using PDM link to display the battery box design allows everyone on the product delivery team to see the current elements of the EBOM design view. Setting the filter to MBOM allows team members across the organization to review the results of the EBOM to MBOM transformation. The displayed MBOM structure detail provides insight into the manufacturing strategy. Using visualization, the external and internal components are clearly visible. During a design review, it was decided that a label was needed on the face of the battery box door. Using Creo Parametric, the engineer adds a new part to the Creo assembly that defines the label. Following a Creo check-in, PDM Link automatically updates both the CAD assembly structure and the PDM Link BOM. Refreshing the EBOM visualization for the design immediately reflects the results of the design changes. Note that the MBOM visualization of the battery box is reflecting the earlier design configuration. The Manufacturing Associative Part Structure browser is open to update the previously transformed MBOM to reflect the new door label. Refreshing first the EBOM and followed by the MBOM results in the maps be displaying both the current BOM structures and the corresponding visualizations. Note that the top assembly MBOM part is displaying a clock icon indicating that it is out of date in relation to the EBOM equivalent part. Starting with the top part, the Update to Current Upstream Equivalent Object action is applied. This reestablishes an updated equivalence link between the parts. The MBOM cover part is also displaying a clock icon indicating that it is out of date in relation to the EBOM part. The same Update to Current Upstream Equivalent Object action is applied. Refreshing the MBOM visualization shows the new door with a location for adding the design view label. Rather than manually searching for the label part in the EBOM, the Reconciliation Assistance feature is selected. The tool identifies that the EBOM label part is missing from the MBOM and is highlighted in both upstream panels. Using a copy-paste action, the label part is added to the MBOM, and the visualization panels for both BOMs are updated to reflect the action that was taken. Re-executing the discrepancy search returns an empty list indicating that all of the EBOM components are included in the MBOM. As the final step in the EBOM to MBOM transformation process, all updates to the transformed MBOM are checked into the PDM link database. Utilizing the MBOM view on the PDM link part details page, we can see that the updated MBOM is now available for sharing to the entire product team. The focus of this demonstration was to highlight the value for your product development teams to be able to simultaneously complete the design and manufacturing engineering activities in advance of a production ramp-up. This will shorten your product's time to market and reduce the cost of change and the cost of manufacturing. Now let's do a review of what you have seen during this demonstration. We started by completing the EBOM to MBOM transformation for an initial design. We then highlighted the capability to share the manufacturing and design engineering results to the entire product development team as MBOMs and EBOMs with 3D visualization. We showed how a design review triggered a change to the original design that resulted in a label being added to the battery box cover. The final steps of the demonstration included an incremental update to the initial transformed MBOM using the Manufacturing Associative Part Structure Browser. Thank you for your attention during this demonstration. Please attend the production planning session to see how the BOM transformation output supports the completion of the manufacturing production plant. To learn more about PTC's BOM transformation tools, use the URL listed on this slide. To schedule a live demonstration or to speak to a specialist, contact PTC Sales or browse to ptc.com/BOM. Thank you again for attending this EBOM to MBOM transformation session.